Top 25 Canadian dollars engineer interview questions and answers. Today, we're diving into an exciting and career-boosting topic, the top 25 Canadian dollars engineer interview questions and answers. If you're preparing for a CAD role in engineering, construction, manufacturing, automotive, or product design, this video will give you the confidence you need to shine. Stay tuned, because each answer is crafted to help you stand out from the competition and impress your interviewers. 1. Tell me about yourself. My journey in engineering began with a strong passion for design and problem solving. Over the years, I've gained hands-on experience working with software like AutoCAD, SolidWorks, CAD, and Fusion 360, designing mechanical parts, assemblies, and detailed technical drawings. I've participated in projects involving prototyping, modeling, simulation, and design optimization. I enjoy collaborating on cross-functional teams, analyzing design challenges, and developing accurate, functional models. I'm now looking for a role where I can apply my CAD expertise and help contribute to impactful engineering projects. 2. What CAD software are you most experienced with? I'm highly skilled with AutoCAD, SolidWorks, and CAD, but SolidWorks has been my primary tool for daily work. I use it for 3D modeling, assemblies, sheet metal design, simulation, and drafting. AutoCAD is my go-to for precise 2D technical drawings, while CAD is excellent for complex surfaces and large-scale assemblies. I'm adaptable and able to learn new CAD platforms quickly, which helps me fit seamlessly into different engineering environments. 3. What is your process for creating a 3D model? My modeling process starts with understanding all design requirements, specifications, constraints, and dimensions. I break the design into features or components, sketch critical profiles, and build the model using parametric features to ensure flexibility. I focus on clean geometry, using constraints and relations to maintain accuracy. After that, I test motion, interference, and fit within assemblies. Finally, I generate technical drawings with proper tolerances and annotations for manufacturing. 4. How do you ensure accuracy in your designs? Accuracy begins with understanding the engineering requirements clearly. I use precise dimensioning, constraints, and parametric modeling to maintain control throughout the design. I double-check references, use geometric relations, and apply tolerances that match manufacturing capabilities. Additionally, I verify models using interference checks, simulation tools, sectional views, and assembly fit analysis. Peer reviews and cross-checking drawings also help eliminate errors before the design moves to production. 5. Explain the difference between parametric and direct modeling. Parametric modeling uses dimensions, constraints, and relationships to control the design. This allows easy modification and updates. Changing one parameter automatically adjusts the entire model. Direct modeling, on the other hand, is more flexible and allows pushing, pulling, and editing the geometry without constraints. It's great for conceptual design and quick edits. I prefer parametric modeling for engineering projects because it ensures consistency, accuracy, and easy revisions throughout the design lifecycle. 6. How do you handle design revisions? Revisions start with carefully reviewing the changes requested by engineers, clients, or project leaders. I update the model using parametric features so modifications do not break the geometry. I maintain version control and document each revision step. I also verify that updates don't affect the assembly fit, performance, or manufacturing requirements. Once changes are made, I regenerate drawings and communicate updates to all relevant team members. 7. Explain GD&T and why it's important. Geometric dimensioning and tolerancing, GD&T, defines allowable variations in form, orientation, and position of features. It ensures that parts function correctly even with minor manufacturing variations. GD&T is essential for communication between design, engineering, and manufacturing teams. I apply GD&T to critical features like holes, slots, and mating surfaces to ensure proper fit and performance. It reduces errors, improves quality, and supports efficient production. 8. How do you approach assembly modeling? I begin by importing or creating individual components using parametric design. Then I assemble them using mates or constraints such as concentric, coincident, and parallel. I check alignment, motion, and potential interferences. I also simulate movement if needed, ensuring the assembly behaves correctly. Once the assembly is complete, I produce exploded views, bill of materials, BOM, and detailed drawings. My goal is to ensure all components fit correctly and function as intended. 9. Describe a challenging CAD project you worked on. One challenging project involved designing a complex multi-component assembly with tight tolerances and intricate motion requirements. I had to coordinate with mechanical engineers, simulate different load conditions, and redesign several components for manufacturability. The biggest challenge was ensuring perfect alignment between moving parts while maintaining strength and durability. Through teamwork, parametric modeling, and continuous testing, we delivered a functional, optimized design that exceeded client expectations. 10. What is your experience with simulation or FEE tools? I've used SolidWorks simulation and ANSYS for stress analysis, motion studies, and thermal tests. I typically begin by defining material properties, applying loads, constraints, and meshing. Simulations help me identify potential weak points, deformation, or failure risks. Based on results, I modify the design to improve performance and safety. While I'm not a full-time FEA engineer, I'm comfortable using simulation tools for basic to intermediate analysis. 11. How do you ensure your designs are manufacturable? I follow DFM principles throughout the design process. This includes minimizing unnecessary complexity, using standard dimensions, avoiding overly tight tolerances, and considering machining, molding, or fabrication limitations. I collaborate with manufacturing teams to understand material availability and tooling constraints. I also verify drafted angles, radii, and wall thickness for injection molded or machined components. The goal is to create a design that's not only functional but also efficient and cost-effective to produce. 12. What file management or PDM systems have you used? I've worked with SolidWorks PDM, Autodesk Vault, and Teamcenter. These systems help maintain version control, secure storage, and structured documentation. I use them to manage revisions, naming conventions, workflow approvals, and user permissions. Proper file management ensures team collaboration, prevents data loss, and speeds up project execution. I'm comfortable navigating and adapting to new PDM environments as well. 13. How do you handle tight deadlines? I start by assessing the project requirements and breaking the work into manageable steps. I prioritize tasks based on urgency and impact. Using efficient modeling techniques and templates helps me work quickly without sacrificing accuracy. I communicate with stakeholders to clarify expectations and avoid misunderstandings. If necessary, I put in focused effort to meet deadlines while ensuring the design still meets quality standards. 14. What steps do you take when starting a new CAD project? I begin by reviewing all design requirements, sketches, reference models, dimensions, and functional goals. Next, I plan the modeling strategy, deciding which features to create first, which parameters to define, and how to build a robust, flexible structure. I gather material data and consider the manufacturing process. After that, I create initial sketches and start building the model. Communication with team members helps align expectations before finalizing the design. 15. How do you work with engineers and cross-functional teams? I maintain open communication throughout the design process. I attend meetings, discuss requirements, review prototypes, and present updates regularly. I listen to feedback from engineers, production staff, and quality teams to ensure the design meets functional, safety, and manufacturing needs. Collaboration helps detect issues early and ensures the final product is efficient and effective. My goal is always to support the team and contribute positively. 16. What experience do you have with 2D drafting? I have extensive experience generating 2D engineering drawings from 3D models using AutoCAD and SolidWorks drafting. I include orthographic views, dimensions, annotations, GD&T symbols, material notes, and tolerances. I ensure clarity, accuracy, and compliance with industry standards such as ISO and ASME. These drawings are critical for manufacturing and quality inspection, so I pay close attention to detail and formatting. 17. How do you minimize errors in your drawings? I follow a structured workflow that includes checking dimensions, relations, tolerances, and drawing templates. I review each view to ensure accuracy and clarity. I perform cross-checks with the 3D model and use drawing compare tools if available. Peer reviews also help catch mistakes that I might miss. Consistency, verification, and attention to detail significantly reduce errors. 18. What is your experience with rendering or visualization? I've used SolidWorks Visualize, Keyshot, and Blender for producing high-quality renders and animations. These tools help communicate design intent to clients, marketing teams, and stakeholders. I create realistic lighting, materials, textures, and motion sequences to showcase product functionality. Visualization enhances presentations and helps teams understand the final product before manufacturing begins. 19. How do you manage large assemblies? I use lightweight mode, simplified configurations, sub-assemblies, and performance settings to manage large assemblies efficiently. I organize components into logical groups and apply display states to control visibility. I minimize unnecessary features, use reference geometry carefully, and limit external relations. These techniques help maintain performance while ensuring accurate representation of the full system. 20. How do you handle design constraints or limitations? I begin by understanding all constraints, material limitations, cost, manufacturing restrictions, safety standards, and space requirements. I explore multiple design options within those limits. Parametric modeling allows quick adjustments when constraints change. Collaboration with engineers helps clarify priorities and make informed decisions. I view constraints as opportunities to innovate rather than obstacles. 21. Describe your experience with prototyping. I've worked on prototypes created through 3D printing, CNC machining, and rapid fabrication. I prepare CAD models with appropriate tolerances and export files in formats like STL for printing. Prototyping helps validate fit, form, and functionality before final manufacturing. I analyze the results, document issues, and update the design accordingly. Prototyping ensures better outcomes and reduces production risks. 22. How do you stay updated with CAD trends and tools? I regularly follow engineering forums, attend webinars, and take online courses to stay updated. I explore new CAD features, simulation tools, and modeling techniques. I also review case studies, read industry publications, and experiment with new functionalities within CAD software. Staying updated helps me improve efficiency and bring innovative solutions to projects. 23. What makes you a strong CAD engineer? My strengths include precision, creativity, and technical expertise. I take a structured approach to design, ensuring accuracy while also being open to innovative solutions. I'm proficient in multiple CAD platforms and comfortable with simulation, drafting, assemblies, and manufacturing principles. I'm also a strong communicator and enjoy collaborating with teams. I take pride in delivering designs that are functional, manufacturable, and optimized for performance. 24. How do you handle conflicts in design feedback? I approach conflicts professionally and with an open mind. I listen to all perspectives, analyze the reasoning, and compare feedback with engineering requirements. My goal is to choose the best solution for functionality, safety, and manufacturability. If needed, I create alternate design options for review. Clear communication and data-driven decisions help resolve conflicts effectively. 25. Why should we hire you? You should hire me because I bring strong CAD expertise, analytical thinking, and commitment to quality. I'm experienced with 3D modeling, drafting, assemblies, simulations, and manufacturing principles. I'm fast, accurate, and adaptable. My passion for design, problem-solving, and teamwork ensures I deliver exceptional results. I'm ready to contribute to your projects, support innovation, and help your company achieve its engineering goals. Thanks for watching. I hope this deep dive into the top 25 Canadian dollars engineer interview questions and answers helps you prepare with confidence. If you found this video helpful, don't forget to like, subscribe, and drop a comment below about which interview topic you want next. Your support keeps the channel growing and helps us bring you more career-boosting content. Good luck with your interview. You've absolutely got this.